In this video, we'll be doing a quick review on topic 5, chemical energetics. All chemical reaction is done by chemical bonding, and during this process, the transfer of thermal energy occurs. If the thermal energy is transferred to the surrounding from the system, the reaction is exothermic. The temperature of the surrounding would increase, and the temperature of the system would decrease. And hence, the energy change of exothermic reactions are negative. And examples of exothermic reactions include combustion, oxidation, and neutralization. And on the other hand, endothermic reaction is when thermal energy is transferred into the system from the surrounding. So the overall energy change would be positive, and examples of endothermic reactions include electrolysis, thermal decomposition, and photosynthesis. Here's an energy diagram showing exothermic and endothermic reactions. And in this exothermic reaction, this is the energy of the reactants and this is the energy of the products. And you can see how after the reaction has occurred, the energy of the products is lower than the reactants, and vice versa for endothermic reactions. Now, for a chemical reaction to occur, particles must collide. However, not all collisions lead to chemical reactions. The collisions must have enough energy and must collide in correct orientation. And this minimum amount of energy required for the chemical reaction to occur is called the activation energy. And you also have to know the definition of enthalpy, which is the transfer of thermal energy during a reaction. Now, for your exams, you will have to know how to identify activation energy and enthalpy change in energy diagrams. So you can identify the activation energy, which is from the energy of the reactants to the transition state for exothermic reactions, from here to the transition state, to the peak, from reactants to the transition state. This would be the activation energy. And the enthalpy would be the difference in energy from reactants and the products. You can see how the enthalpy here for exothermic reactions are negative, and for endothermic reactions, the enthalpy is positive. So you may be wondering, what determines whether a reaction is endothermic or exothermic? The answer lies in difference in energy needed to break existing bonds and energy released when new bonds are formed. So bond making is exothermic. Energy is transferred to surroundings as new bonds are formed. And bond breaking is endothermic. Energy is required from surroundings to break the chemical bonds. So now let's look at how we can calculate bond energy in chemical reactions. So calculating bond energy is very simple. All you have to do is follow these 4 steps. So first, write a balanced equation. Secondly, add all the bond energies for the reactants. And third, add together bond energies for the products. And finally, calculate change in enthalpy by using this equation. Energy taken in minus energy given out. Now let's look at an example. So here we have a problem. Calculate the enthalpy change for reaction and state whether the reaction is exo or endothermic. And here's this equation, and you can see how it's not balanced. So step 1, we should balance the equation. In step 2, we need to calculate the bond energies of the reactants. So here's the reactants. We have 2 HBRs, and then we have 2 HBr bonds, which is 366 kilojoules per mole. And since we have 2 HBRs, we have to multiply by 2. We have to calculate the bond energies of the products. We have 1 HH bonds and 1 BR bonds. If we refer to the table, we can add these 2 values to calculate the bond energies for the products. And now we can calculate the enthalpy change by subtracting the bond energies of the products from the reactants. And as the enthalpy change is positive, the reaction is endothermic.